Well, hi, and thanks so much for joining me in my shop here. I think it's January 14th today. So I think what I'm going to do, especially after seeing the oscilloscope display of what's coming out of the power supply and hearing what's coming out of the speaker on this radio, I think the next focus has to be the power supply. So to that end, I have a lineup of capacitors here to replace most of the filter or all the filter capacitors in here. I'm a little surprised. My experience with these radios is these big filter cans like this are usually not so bad. This one appears to have no capacitance left in it at all, which is, I just find it a little hard to believe. So this guy's involved too. So I think I'm going to test these as best I can before I do anything. Some of them I can lift like this. I can lift one leg off and test it, and just to see what is going on here. Because it was a pretty sad display. Let's do the test. These are electrolytic. They're large capacitors. So in terms of doing a capacitor test, I can use long leads if I can find them here, and still have a valid test. Because the leads themselves have a little bit of capacitance, and these are long clip leads I'm using here. Their capacitance is, I'm going to take a wild guess, probably 5 picofarads, something like that. Well, if you're measuring a very small capacitor, you certainly can't do this with these long leads. This guy's in the circuit. I'm quite likely to replace him, so I think why don't we give a shot at desoldering it. I was looking at it a little closely, this connection here. Whoops. And it could be that this has been installed after the fact. That's my CB radio unsquelching there. Let's see what we can do here. It looks like this capacitor is just tacked in, but it may not be. Oh yeah, look at that. It's just tacked in. I bet you it's the same down here. I'm going to leave it connected down here. So that's a very good sign that this was a replacement. I don't think in the factory they would tack it in. This end's negative, and this end's positive. There we go. And this is supposed to be 100 microfarads. Okay. Let's take a look here. Okay, so we're ready to test this capacitor. Now this capacitor's rating is only 25 volts. So my first test, even though you can see it says 25, actually puts 50 volts onto the capacitor. So this will be it for a leakage test. Watch the eye. It should close and then open again. It might take a little while. Ooh, that looks like it stopped right there. Just this power factor control having no effect at all on it. I don't think that's very good. Well, I think it should come all the way open. That's only 50 volts. What we'll do is we'll try the same test with its potential replacement capacitor, which has come out of my my vintage capacitor stock here. So there's some question about this one. That's the replacement though. 100 microfarads, 25 volts, same as the one that's in there. Made in the USA. So we'll go negative here, positive here. Once again, the long lead wires won't matter. It's clipped fairly well there. Okay. And how do you do? On the 50 volt again on a 25 volt capacitor. There we go, opening right up. Okay, we're going to give it a moment to discharge, and then we'll try measuring the capacitance on it. It's supposed to be 100. 20 to 1000. 20 to 1000. There's the spot right there. And we are on 21,000. We are right around 100. It's 100 right there. Very good. Capacitor, my vintage replacement capacitor is good. Just how vintage it is, I don't know. I don't think it's that old. Great. Okay, now we want to try to test the we would like to try to test the main capacitors here, but they're in the circuit, which is kind of nonsensical for me to try. It would be foolish to try in here. Let's take a close look at the arrangement in here, because you can't see it with this camera. See if we can see more with this other one here. We're looking right down on the capacitor. And what's going on in my head is I'm thinking about how am I going to work on this. So I have some options. One is to cut all these wires free, all of them. And then with the wires free, reattach them to the appropriate capacitors in this area. All those ones that were on my bench. Another one is cut free the terminal. Cut it way down on the bottom here where you can't see what I'm pointing at. Way down. Cut it so the terminal and all the existing wiring remains the same, but there's no connection to the old capacitor. And solder the new capacitors onto the existing terminals. I like that idea. I do like that idea. There's a ground connection here, like to the, or negative, let's call it negative, I better not call it ground. Negative to the can here. And there's another one behind this capacitor. Now this capacitor, in the service manual, there's a photograph of all the parts in the radio. This capacitor appears, and it's not wax. It's a bumblebee. So we've had this yellow one down here that apparently is a replacement. There's a good chance this guy's a replacement too. It's in the way though, that's what I'm thinking. I mean, it's wax, so I may want to get rid of it anyhow. It looks to be good, but looks can be deceiving. So I would think about removing this just to get better access to everything down there. Now we have this great big resistor in the way too, but I think I'd rather just leave that alone. I don't think I want to fool with it. You see one of the terminal connections is sticking out a little bit here. You know, that might be a sign of overheating at the terminal. I don't think it is though. It might also be a sign of expansion and contraction as it heats up and cools down, and it just popped this little piece off here because of the funny shape. So this measures at 2,000 ohms. It looks great. I can't imagine replacing it, and I don't want to cut it free if I can avoid it, because it's just more working of the terminals and just a greater chance of, you know, the work itself introducing more problems. So I'm going to work in this area. Out a little bit here. I gotta find enough places for all those capacitors. I guess I just tuck them in one at a time and just work my way through it one at a time. Then I gotta be able to get the cutters up in there and cut free those terminals, and that's about the scariest thing of all. I have to use a fairly heavy duty cutter. Oh, I gotta get, how am I gonna do that? Some of these might be fairly easy. So, you know, it sounds great, cut them free after you're done, but holy smokes, how are you going to get in there to do it? So I'm just practicing here a little bit to see what might be involved. So a couple of these terminals I wouldn't have to cut free. They're going to the can. I could leave the can of the capacitor connected and Just make sure none of these other terminals are in contact. There's no harm in leaving the can on there, I'm pretty sure. So I don't have to try to cut this ground thing off here. Oh, what's happened to the focus? So I'm letting the automatic focus operate here. This guy is really in the way. Can move him a little bit out, a little bit. I think that's the plan. I think the plan is to install the new capacitors on these terminals and then try to cut the terminals free and just deal with all those challenges when they come. I can cut them free now, but I cut them free, I get to move them a little bit. I could lift them up and move them out or wherever if I were to cut them. I'm cutting them with less stuff hooked up too. Because if I cut them after putting in all those capacitors. Wow, I think I'm having trouble getting this in there now. There'll be four more capacitors jammed in here. So it sounds like cut them free, then solder to them. And I'll discover in that process if I can even achieve this. Cut first, solder second. Gives me more flexibility. This capacitor, where is he going? He's going across to the far terminal. So I should photograph this also before I start. And then do it. Okay, I know what I'm going to be doing for the next hour or so. Okay, so I've swung this capacitor out of the way here. Nipped it and swung it. And I'm trying to pick one of these terminals to chop off. And I realize I can test the capacitor after that, once I have a terminal off. Let's see, how's this gonna go? Let's see if I'm strong enough to do this. Okay, we never know how strong these terminals are. Stronger than me. Okay, let me nip it here a bit. Boy. Actually, it looks like I'm cutting it without realizing it. Yeah, they're not hard, they're easy. Okay, I got one off. And I've left the terminal there. We can get in there and test that. Yes, we can. We can all climb in there. I think that's okay. Okay, let's take a look over here. Now, I don't know what size section I'm on. Should be able to find out with this. 50 volts. Set for electrolytic. Just opens a tiny little crack. Well, my experience in testing electrolytic capacitors with this machine is not all that great. Certainly with a regular capacitor, I got a really good feel now for what a good capacitor and a bad one looks like on here. Electrolytic, I'm not so sure yet. I think we prefer this to come open though. It's only 50 volts here. Okay, let's try measuring its capacitance. Nothing showing up. On this scale, that was 20 to 1000. I'll do 0.1 to 50. Nothing showing up at all. smaller. This is crazy now. Okay, so whoop. So anytime this eye reacts at the end of the scale, you gotta ask yourself, is this valid in any way? It probably isn't. So I think we can call that quite inconclusive, but this is telling me there's no capacitance left in that capacitor, which is really kind of far-fetched, I think. Zero capacitance? On the other hand, this guy was humming like it had no filter capacitor. Okay, so the only conclusion, really based on all the observations, is that the capacitor is shot in this radio like I've never seen before. So that's encouraging. That means repairing it or replacing it is going to have a big effect on the radio. And it's really worth doing. So I'm going to get on with that. I can get the terminals off. Everything's working out great. Yahoo! Okay, that's the first one in, and that turned out to be the 80, one of the two 80s, the high voltage 80 that tested like it wasn't even there. So that might explain all the humming. Maybe that's enough right there. I should stop. But let's go on to the next one here. I can't know. I mean, you can only assume the rest are just as bad, really. Sure, this is one of the 40s here I'm trying to nip. Now I can move this just a bit here. There. I'm sure it sounds worse than it really is, that grinding. That's because of the microphone position you're listening to. Okay, so this can be lifted out quite a ways. There. A 40 goes there. This would be a 40 here. So you want to use a different style. So it's got the leads coming out the end. I don't think that's quite going to be good. Okay, no problem. Oh, wait a minute. Hold on, you get to test them. Get to test it. Okay, what about this? $50 electrolytic. I'd say now that's opening a bit more than the other one. Let's hit it with 150 volts. Again, my experience here, well, you're seeing me get it. It's just barely open. But we know the radio works terribly. The suspicion is it is these guys All their fault. Okay, I've got all the capacitors changed in here. I got 4 here, this one, which replaced this one here, and another very large electrolytic here, and that's it. So let's test this one. This one turns out to actually, although it's sitting here in the radio, electrically it's across the primary of the output transformer. So let's give this one a check. And we're going to try operating that radio and see what happens here. So my guess is this one's going to test good, but we'll see. Okay, regular capacitor setting, watching the eye, operate open. 250 volts. Oh, not so happy at 250. Okay, so like any capacitor that's been around for so long, it's bound to be a little leaky. But not too bad. I don't know the consequences in that particular position, if that's a critical factor or not. Somehow I think it probably isn't. But anyway, new capacitor in. What now? Now we want to monitor the voltage at the top of the heater string in this radio because it's so critical and I'm so nervous about it. So a good ground point is going to be right here. This is B minus connection going to the voltmeter, and then we want to get on pin 7, 3V4, which is down here. So that's going to give me the voltage of the string, and I'm pretty sure I should be reading 9 volts there. I'm just double checking now to make sure. So I should read 9 volts to there. Right. Okay. This is set on 20 volts DC. And we're still going to try to operate from this transformer in the box here, a mystery box. So the radio is going to run on about half the normal line voltage. So my expectation is this would come out to be about half what it should be. Last time it came out to 8 volts, which was a little bit disturbing. Now I fixed up the power supply. Goodness knows the oscilloscope. We should have the oscilloscope ready. We should have the oscilloscope. The oscilloscope painted a pretty ugly picture of the filtering in this radio. Very ugly. Ugly, ugly. Okay, so we're going to want to go to B minus also. I don't know if I can get on with that clip there. Room for 2? Yeah. And then this, we can clip it and leave it right on. This is set to ×10, which shouldn't matter though. Pretty much any one of these. But any one of these capacitors. But let's take the big 150 volt one. That's where we tested last time and just saw what looked like 0 filtering. Now I think on the video it may not have come across very well because of a shuttering action here. Let's see if I can get rid of some of that. See what that looks like. We're on the 5 ×10, 50 volts per division. Expecting this to end on DC. Okay, but the critical one is this one. Again, I don't have any way to start this up kind of slowly, so it's all going to be there as soon as I hit the switch. All half of it. All 70 volts or so. Is there anything here I need to think of more? Is it turned on? No. It's turned on now. Volume up a bit? I don't think we needed the volume up a bit last time. What about reading the B plus voltage? The B plus voltage, does that appear? That's a good idea. Does that appear on the schematic? Well, we can guess it should be around 90 volts because that's what you get out of the batteries. So if we care to check, it would be 90. 90 right on the capacitor that I'm on now. roughly 90. 90 would be 2 divisions. Would be above 90. Okay, I think my head's in gear now. Okay, we're still going to run the dim bulb. That shouldn't matter. Goodness knows what's going to happen. 3, 2. Okay, so I saw this jump up appropriately. This guy's down to 3 now. No screaming hum coming out of the radio. Turn it up. Okay, now, no surprise it's not working. It's only being fed with half voltage. Looks to me like I can plug this guy in the wall. That's the impression I got, because this has dropped. Isn't that interesting that this would come down? Good, that's good so far. Okay, switch off, power off. We will up the ante here. Okay, so upping the ante means okay, everything's in the way. Upping the ante means running the we're going to run this at whatever Niagara Falls is offering today. You might wonder, do I really get my power here from Niagara Falls? Well, probably not. It's quite a ways away. Maybe at night. Don't think so though, because there's lots of nuclear generation here in Ontario. I live not too far from the world's biggest nuclear plant. Actually, I'm not close to it by any means significant. Called Bruce Nuclear Plant on Georgian Bay. Okay, now these are going to have 120 volts on them, so anything stupid going to happen? What if I swing this radio around? I kind of forget all that. I can't swing it around. No, they look fine. They look fine for now. Okay, so we're going to have all the same equipment connected. Nuclear power. What a shame the world turned its back on nuclear power. What a shame. What a shame, I say again. Okay. Ready for another shot at this. So I'm going to be able to see the voltmeter, the oscilloscope. This time we'd expect sound to come out of it too, because basically it should operate, except for many other problems that may be in the radio. Okay, I'm just thinking hard here. So volume up a little bit. This is it. Blow these tubes up or not. Okay, watching this. Come to 9. Oh, excellent. I'm happy about that. Doesn't guarantee I haven't blown up a bunch of tubes, but I'm pretty sure I haven't. How about some sound? There is sound. Very hard to hear. It's very, very faint. We have no antenna. Don't know what band I'm on. Let me put it on. Okay, danger. I'm going to turn this. In fact, I won't turn it. Smarter way. Move the camera over here. Let's get this guy onto the broadcast band. Okay, volume down, because things may get very loud. So there should be a band indicator in here. I don't see a band indicator. Big band switches here. Good luck on me turning it by hand without the dial. Let's get the dial out. You don't have to take the dials off this radio. This is the one here. Hey, something scratched on the back of it. Peter Cheredinuk, Nord Street, Toronto. Ha! I've got your radio. that just popped up. What is this? What's this setting? Setting of nothing. Well, there is a setting of nothing. So, okay, we're on this band now. Come on, baby. See what you can do here. What can you do? Oh my gosh. Okay, let's tune this guy. Ha! It's a radio. Fading out. Okay, here's your, come on radio. Do your stuff. Really fading, just fading right out. Right in the key spot. Okay, volume up full. Well, not picking up a station, but can't complain. It's picking up noise, which is good. And then we'll take one shot on shortwave. We'll go up to this. Oh, I gotta get my antenna here. Maybe if I put this antenna on, the AM will work better too. Okay, antenna connections. Oh, just gonna reach around. Brings in a lot of noise too, of course. I think it's really, really hopeful. I don't know if you're like me, I can hear voices in those sounds sometimes. Hey, we're still reading B plus on the scope, and it's running at about, it would be 130, 120, 120, something like that. So, shortwave band. That was interesting. 31 meter band. The noise getting louder. I'm thinking, it's more likely going to get something, but I'm afraid not. And we'll take one more shot. We'll go up. You know what I'm going to do? Just hold the fort here for a moment. Okay, so just checking to make sure my antenna was switched on. It was. I never connected the ground. Let's connect the ground here. Oh, came right off. And the other thing we should do is a temperature test on this radio too. I'm getting too excited. I'm too excited, man. I'm so excited. Brother Stare. No, that's not Brother Stare.
Into the storehouse, that there may be food in my house, and try me, test me. Now in this, if I will not open the windows of heaven and pour out let me roam in their futurist. For needing to test him in order to build your faith. No. In the country.
WWV. Let's see. .2. So that's ham radio. Whoops. The radio just jumped frequency. That sound is ham radio. Just above 10. 10. Well, looks like the dial might be really accurate. Let's go up to 15. I'm sure it's not supposed to make that noise when you switch bands. They would have done something about that. Oh, 1 too high. No? Good. That's not typical static for this band. So I get the impression the AVC is not very active in this radio. 15 should be right on the 15. Is that supposed to be 15 way over there? Faded right out. Good show. That's enough of that. That's great. Switch off here. Well, okay, that's better than I would have ever imagined was going to come from just doing those capacitors. Wow. So, reception kind of so-so. We'll just start working on it. We'll maybe start with the audio side and just do the usual. We'll go through the capacitors and the audio side and take 1 or 2 of these red ones out and check them and see how, if they're leaky or not. They probably are. And just work our way through the radio in the hopes of coming up with a really nice shortwave radio that I can take down to the beach with me. That would be great. So thanks a lot for watching, and we'll see what happens tomorrow.